Okay, so today we'll solve GET 2022 mathematics question. This is the question number 22 from topology. It is saying that let's consider this 0 1 with T1 where T1 the subspace topology from R. So 0 1 is taking the subspace topology from R and T2 be any topology on 0 1. Then statement P is saying that if T1 is proper subset of T2, then 0 1 with respect to T2 is not compact, and the question Q is saying that if T2 is proper subset of T1, then 0 1 with respect to T2 is not housed up. Okay, then you have to say which options is correct. This is the 1 mark question, and for this is the NPTEL reference. This you can look into it. Okay, so let's first check whether P is true or not. Okay, so what is given first? Given that the statement for P is given that if T1 is a proper subset of T2, right, then it's given that T1 is a proper subset of T2. Then we have to check that 0 T2 is 0 1 with respect to T2 is not compact. So what is the meaning of this? This is the same as that saying that if you take the identity operator from this space 0 1 with T2 to 0 1 with T1, it is saying that identity map is continuous. Right? Why? Because if you take any open set means so take any open set here, it is so U is in T1 mean U is open. So as any open set is open in T2 means, and this is basically identity operator. So if you take inverse image, it will basically I inverse of U, which is again U, which is again open in T2, right? So if U belongs to T1, which imply U is also belongs to T2, right? So which means that I identity operator is continuous. Identity map, not all. So now we have to prove that this 0 1 with respect to T2 is not compact. So let's assume, suppose 0 1 with respect to T2 is compact. Then let's see what will happen. So we'll prove that basically if we assume this, so we'll prove that this is not compact. So we will get a contradiction. So we'll show that if we assume that this is compact 0 1 with respect to T2, then this topology becomes the same. So let U is in T2, you take an open set in from topology with respect to T2, we'll say that this is also open in T1, which implies T2 means U is open, right, in T2. So then take the complement with respect to 0 1, let's define it A 0 1 minus U, then this is closed, right, because U is open, so this is closed in T2, right? Now note that T1 is a subset of T2, as T1 is a subset of T2. And what is T1? T1 is the just subspace topology from usual R. So obviously this T1 because subspace topology, because R has house drop, R is house drop, so the subspace topology it will also become house drop. So obviously 0 1 with respect to T1 is house drop, and as T2 contains T1, so means if you take any 2 points, then you will find open set from T1 which will separate these 2 points. So these 2 open sets also belongs to in T2, means T2 is also house drop. So therefore 0 1 with respect to T2 is also house drop. Right, because T1 is a subset of T2. And we have assumed that this is compact. So what we get, T2 is compact and house drop. So 0 1 with respect to T2 is compact house drop space. So in a compact house drop space, every closed set is compact, right? So therefore, because A is closed in T2, so which implies A is compact in T2. So we get that A is compact in T2. Now because identity map is continuous and compact image of a continuous image of a compact set is compact, so as continuous image of compact set is compact, so because I is a identity is continuous map, so I of A, which is again identity, is compact in T1, right? In T1, because identity takes T2 to T1, so this is compact in T1 and T1 is a house drop, right? So any because compact set, when compact sets are closed, if compact sets are in house drop space are always closed, as 0 1 with respect to T1 is house drop, so A is closed in T1, right? So A is closed in T1, which implies its complement is open, which implies U, which is the 0 1 minus A, is open in T1. Okay, so we have start with, so means which implies U belongs to T1. So whatever opens, we have started with open set with T2, we have shown that this is also an open set in T1, but we have assumed that T1 is strictly contained in T2. So from here, so this implies that T2 is same as T1, but which is a contradiction, right? Which is a contradiction. This is, let me write therefore, which is a contradiction. So therefore, what is our assumption? That this is compact, so 0 1 with respect to T2 is not compact. So 0 1 with respect to T2 is not compact. Okay, so therefore statement P is false. No, statement P is true, right? P is true means it is saying that it is not compact, so P is true. Okay, now let's check the statement Q. It is saying that if T2 is a proper subset of T1, then 0 1 with respect to T2 is not house drop. Okay, this time its T2 is strictly contained in T2. Right, so therefore again we have, so this is same as earlier. So we take the identity map. So now this time we take it from 0 1 with T1 to 0 1 with respect to T2. Now this become continuous, right? Why? If you take, if U belongs to T2, which implies U is also belongs to T1, right? As, which is meaning that identity map is continuous, right? Now I assume that, let's suppose zero 1 with respect to T2 is house drop. Then again we will arrive at a contradiction, that we will show that these two topology become the same. So let's start with the open set with T1. Let U is in T1, which implies U is open in T1. So then let's take the complement. Zero 1 minus U is closed in T1. Right, and this is 0 1 with respect to T1. This is basically the subspace topology from the usual topology of R. So therefore this is both, so as 0 1 with respect to T1 is subspace topology induced from usual topology of so therefore G1 with respect to T2 is both compact and house drop. So G1 with respect to T1 is compact and house drop. So in a compact house drop space, every closed subspace, so this is a, means in compact house drop space closed subsets are compact. So therefore A is compact in T1. Now again, as early continuous image of a compact set is compact as continuous image of compact set is compact. So I of A, which is again A, is compact in T2. Now we have assumed that 0 1 with respect to T2 is Hausdorff. So in Hausdorff space, every compact subsets are closed. So as 0 1 with respect to T2 is Hausdorff, this is our assumption. So which implies A is closed in T2. So is closed in T2 means its complement is open, so which implies U, which is the complement of A, is open in T2, which means that U belongs to T2. So we start with the T1 and it's shown that it's in T2, and as obviously T2 is subset of T1, so this implies that T1 is same as T2. These two topology become the same, but which is a contradiction, because it's given that T2 is, I think, a strict subset of T1, so which is a contradiction. So therefore we have assumed that 0 1 with respect to T2 is Hausdorff, so this is not true. So 0 1 with respect to T2 is not Hausdorff. So Q is also true. So therefore both the statements P and Q are true. That if T1 is a proper subset of T2, then 0 1 with respect to T2 is not compact, and if T2 is a proper subset of T1, then 0 1 with respect to T2 is not Hausdorff. So therefore option B is correct. Both P and Q are true. Right? Okay.